US Physics Olympiad, year 2010, USAPHO, Semifinal. Problem B1. A thin plank of mass big M and length big L rotates about a pivot at its center. A block of mass M small, much less than M big, slides on the top of the plank. The system moves without friction. Initially, the plank makes an angle θ0 with the horizontal. The block is at the upper end of the plank and the system is at rest. Throughout the problem, you may assume that θ much less than 1 and that the physical dimensions of the block are much smaller than the length of the plank. Let x be the displacement of the block along the plank, as measured from the pivot, and let θ be the angle between the plank and the horizontal. You may assume that the centripetal acceleration of the block is negligible compared with the linear acceleration of the block up and down the plank. Questions. Question A. For a certain value of θ0, x equal k θ throughout the motion, where k is a constant. What is the value of θ0? Express your answer in terms of big M, small m, and any fundamental constants that you require. Question B. Given that θ0 takes this special value, what is the period of the oscillation of the system? Express your answer in terms of big M, small m, and any fundamental constants that you require. Question C. Determine the maximum value of the ratio between the centripetal acceleration of the block and the linear acceleration of the block along the plank, writing your answer in terms of small m and big M, therefore justifying your approximation. Question D. Count what is kinetic and potential energy of the system in any particular moment. Solutions. Question A. For a certain value of θ0, x equal k θ throughout the motion, where k is a constant. What is the value of θ0? Express your answer in terms of big M, small m, and any fundamental constants that you require. So first let's write equations for motion, for block and our plank. For block in any particular moment, we have this equation that mass multiplied by acceleration equal negative mg multiplied by sine θ. For rotation of our plank, we have equation that I alpha equal negative mg x cosine θ. Now, because θ is always much less than 1, we can rewrite this equation in form of this one, that the acceleration of block equal negative g θ and 1 over 12 big M L square alpha equal negative mg x. Now, because we expect that our motion is synchronized, it means that oscillation of this block same angular frequency as rotation of this plank, so we can write this harmonic motion equations. So we assume that θ starts from the top position. It means that θ equal θ0 cosine omega t, and now we can assume that block starts with highest position. It means that x equal L over 2 cosine omega t, and our plank starts from angle θ0, and equation will be θ equal θ0 cosine omega t to synchronize our motions. And now we can count what is the angular acceleration of this motion, and what is linear acceleration of motion of this block. We just need to take a second derivative from this expression by time. So we have expression for angular acceleration, this one, and we have expression for linear acceleration of the block is this one. And we can insert these values to this and these equations. So we have this and these expressions. And now we can count what is omega square here and what is omega square and equalize them. So from this equation we have omega square equal this expression, and for this equation we have omega square equal this expression. After equalizing them we have expression for theta 0. That's this one, and because small m much less than big M, we can conclude that theta 0 is small enough. So that was answer for question A. Question B. Given that theta 0 takes this special value, what is the period of oscillation of the system? Express your answer in terms of big M, small m, and any fundamental constant you required. So here we already have expression for omega square, and we can put this theta 0 here. Now we can find that omega square equal this expression, and from here total period will be this expression. So that's the answer for question B. Question C. Determine the value of the ratio between the centripetal acceleration of the block and the linear acceleration of the block along the plank. Writing your answer in terms of small m and big M. Therefore, justifying your approximation. Solution. To solve this question, we need to leave these expressions. And now let's count what is centripetal acceleration. In our case, centripetal acceleration for our block equal this expression. That's the first derivative from angle by t square multiplied by distance x, so which is given at this expression. Linear acceleration. For linear acceleration we have this expression. Now we need to divide this centripetal acceleration by linear acceleration, which will give us this answer. That's 3 small m over big M multiplied by sine square omega t, which is always very small. So that's the answer for question C. Question D. Count what is kinetic and potential energy of the system in any particular moment. Let's count what is kinetic energy. That will be kinetic energy for linear motion for our block, and rotational energy for plank. That will be this expression. That's 1/2 mv square for block plus 1/2 I omega square for our plank. And we can count what is dx over dt. We already did this. And what is d theta over dt. After counting, we can put these expressions. This is our kinetic energy for block, and this is our rotational kinetic energy for plank. We can rewrite it in form of this one, and because theta 0 equals this expression, we can put it here and find final expression for kinetic energy. That will be this expression, and to simplify it, we can use theta 0 to express it like this one. Now let's count what is potential energy for the system. That will be just potential energy of this small block. Potential energy equal mgh, where h approximately equal x multiplied by theta. And we can insert expression for x and theta here. That will be this one, and finally got this one. So we have for kinetic energy this expression, and for potential energy this expression, which is quite understandable, because total energy equal kinetic plus potential, which is this one. And if we look at this formula, that will be potential energy in the initial position, where theta equal theta 0. So that's the solution for question D.